Welcome, my friends. Consider the expression 3 times x plus 2. We know from the distributive property that this can be simplified by distributing the 3 to the x and the 2. The result is 3x plus 6. But what if we wanted to go backwards? What I mean is, what if we were given 3x plus 6 and asked to revert back to the undistributed form? Well, we would have to ask ourselves what both 3 and 6 have in common. Well, the largest number that evenly divides both numbers, sometimes called the greatest common factor of 3 and 6, is 3. Therefore, we can quote-unquote pull out a 3 from this expression. Then we ask ourselves, 3 times what gives us back 3x? Well, x times 3 is 3x, so we need to put an x here. Then we ask ourselves, 3 times what would give us 6? Well, 3 times 2 gives us 6, so we need a 2 here. And voila, we are back to the undistributed form. This process of going backwards from the simplified form of an expression back to the undistributed form is called factoring, which is an extremely important part of algebra. Let's try another example. Say we are asked to factor 12 plus 8x. We need to think about what the greatest common factor of 12 and 8 is, meaning what is the largest number that can divide both 12 and 8 and still result in a whole number. Well, the factors of 12 are 1, 2, 3, 4, 6, and 12. These are all of the numbers we can divide 12 by and still get a whole number. The factors of 8 are 1, 2, 4, and 8. The greatest number common to both lists is 4, so 4 is the greatest common factor. That means in the factoring process, we write a 4 outside of the parentheses. Now we ask ourselves, 4 multiplied by what number gives us 12? Well, 4 multiplied by 3 gives us 12, so the value in our first blank must be 3. Then we ask ourselves, 4 multiplied by what number gives us 8x? Well, 4 multiplied by 2x gives us 8x, so we need to have 2x in this blank. And there you go, we have reverse distributed our expression, more commonly called factoring. If you want to check whether or not you have factored correctly, you can distribute and see if you get the original expression back. Distributing, we have 4 times 3, which is 12, plus 4 times 2x, which is 8x. This verifies we have factored correctly, as our result is the same as what we started with. Let's try a problem with variables on both terms. We are asked to factor 6x to the third minus 4x squared. Now that we have variables on both terms, you kind of need to think of our constants and variables separately. Ignore the negative sign for now and just think about the constants 6 and 4. Hopefully you can verify that 2 is the GCF of 6 and 4. 2 is the largest number that both 6 and 4 can be divided by, and for the result to still be a whole number. Now that we have a variable, we have to think of the GCF of our x term as well. It's actually easier than the constants. X raised to whatever is the lowest power of your terms will be the GCF on x. So in this case, the GCF is x squared. X squared is the largest power of x that could be divided evenly into both terms. Anything higher and we would start to have negative exponents. So altogether, our GCF of 6x to the third minus 4x squared is 2x squared. So we write this next to an open set of parentheses. For the first number, we need to ask ourselves, 2x squared multiplied by what value gives us 6x to the third? Well, that would have to be 3x, as 2x squared times 3x is equal to 6x to the third. For the second blank, we ask ourselves, 2x squared multiplied by what gives us negative 4x squared? The answer is negative 2, so our second blank must be negative 2. Our final answer is 2x squared times 3x minus 2. Of course, you could always distribute to make sure your final answer is correct. 2x squared times 3x is 6x to the third, and 2x squared times negative 2 is negative 4x squared, which matches our original expression, verifying that we have factored correctly. Let's try a multivariable problem. We have 32y to the fifth x plus 8y to the fourth x to the seventh w to the sixth, which we need to factor. For our constants, the GCF is 8, as both 8 and 32 can be divided by 8, and the result will still be a whole number. For each of the variables, we need the smallest power in common to both terms. For y, the smallest power is y to the fourth, so the GCF is y to the fourth. For x, the smallest power is x to the first power, which we see in our first term, so the GCF is x. For w, there is no w at all in the first term, so we don't pull out a w at all. Our GCF is 8y to the fourth times x. Now we need to ask ourselves, 8y to the fourth x times what will make 32y to the fifth x? Well, our constant must be 4, as 8 times 4 is 32. For y, we need one additional y, so we have y to the first power. And for x, we don't need anything else, since we already have the only x we need in 8y to the fourth x. For the second blank, ask yourself, 8y to the fourth x times what will make 8y to the fourth x to the seventh w to the sixth? Well, we already have 8, so we don't even need a constant. Same thing for y. We already have y to the fourth, so we don't need any more y's. For x, we have 1, but we need 6 more to make 7, so we need x to the sixth. We don't have any w's in our GCF, so we write the entire w to the sixth in our blank. Our final factored form is 8y to the fourth x times 4y plus x to the sixth w to the sixth. Okay, let's try one more. We have 9u v to the fourth w to the sixth minus 30u to the third v to the ninth w squared. You should hopefully be at the point where you don't need to separately write out the GCF for each variable, but if you need to, you can still write it down. I'm going to go straight to writing out the factored expression. Our GCF of 9 and 30 is 3. Just ignore the negative sign for now. We will worry about that later. The smallest power on u is the first power, so we factor out a u. The smallest power on v is 4. And for w, we have the second power. So the GCF is 3u v to the fourth w squared. Our first blank must begin with a 3, as 3 times 3 is 9. We don't need any more u's or v's, but we need 4 more w's to make 6, so we have 3w to the fourth for the first blank. For the second blank, we have negative 10, so that 3 times negative 10 equals our negative 30. And then we need 2 more u's, 5 more v's, and no more w's. So our final factored form is 3u v to the fourth w squared times 3w to the fourth minus 10u squared v to the fifth. Alright, my friends, that completes our video introducing factoring.